Alright, so I'm gonna show you this visualization of Millbrook flooding. It's programmed using Unity. It's using the UFlex library in Unity, which is a GPU optimized particle simulator. So I'm representing water as lots of little balls that just fall and follow gravity, a bit like a giant snooker ball simulation in a way. So let's start it. This is a program that can run pretty much on any Windows PC, actually Windows, Linux and Mac, but the problem is you need to have an NVIDIA graphic card to use all this optimized computation. So yeah, like one of these graphic card used for gaming and stuff, in gaming laptop or gaming PCs. So yeah, you can define, I recommend to run it as windowed, whatever graphic quality you can afford to run depending on your machine, and you click play. And then there's three source of drainage pipes overflowing. So I'm just simulating a particle emitter that's located in this particular place. So you can see there is one at the center of the village near the reservoir, and it's in red. There's another green one. The emission is where the pipe is blocked. The drainage pipes is blocked over here. And then there's another one. There's another kind of drainage pipe, I think, I'm not 100% sure, but I think it was blocked around this area where the particle fountain is located. So you can see nicely all these balls follow gravity. They roll, they interact together a little bit like a liquid. Not exactly, there is a few modification to make it work. You can see a couple of things is when there's a lot of balls near each other, then they're under a lot of pressure, and sometimes they tend to jump a little bit because due to the physics engine they're a little bit elastic, if you want. Not much I can do about that little behavior, but overall it's not really a big problem once you start zooming out and you see how things are happening. It really looks like a water flow, and it's quite satisfying to watch actually. And you can see that in that instance the red emitter has stopped emission. All my emitters have stopped. They were just rigged for a limited amount of time to emit particles, and now they just follow the topology of the terrain. And you can see that although the surplus in the red area goes into the reservoir nicely, there is still a big kind of bowl shape in this area, so you can see that it is still not optimal. It's not really the topology doesn't really make it easy to empty in the reservoir. It mostly stays stationary in this area, in the enclosure of the bottom of the village. And here you can see that the water that came from pretty far away has gone down the hill and is still going down. I mean water, the simulated particles. And at first it came upon that obstacle, but then didn't really stop it for very long, and it stays confined to the right part of the village, if you look at the central part being this road. So the brown particle comes from this drainage pipe that was built over in the heights over there. And you can see the contribution of the green portion, and it's not actually static. They kind of move slowly. So if you were to wait for a long time, you would actually see very, very slowly the pressure building from the center of the village, pushing the particles slowly into the reservoir. So in the end it wouldn't be completely empty, but you would get probably less going on around the center. So as I said, they're jumping because of the physics simulation. Once there are too many particles on top of each other, the pressure makes them pop out and jump a bit. The nature of the physics engine I'm using But if I zoom out, you can now see a pretty interesting, I don't know if it's accurate, but a pretty well, um, telling picture of the village. So this is Millbrook. This is what's left once you've emitted particle from 3 locations, which would be roughly placed where the drainage pipes were blocked. Hopefully that should be of some interest. Lots can be played with there. I mean, you can make some particle disappear if they hit a particular area, which might be some sort of drainage area, or you can change the velocity at which the particles are emitted depending on an estimation of the water flow. But I don't have all these data, so if I've got some data, I guess I can do a bit more about that. But yes, that's what it looks like. Thanks for listening. Bye bye.